Okay, so the video just stopped and let's continue, okay? When I draw this, and as you can see that it satisfies the horizontal test, which is a one-to-one. And of course, it has an inverse, okay? And we can easily just solve its inverse, right? Remember set y equals f of x, right? Y equals x squared, interchange x and y, just x equals y squared. Since y is positive, then y equals square root of x, right? And also replace y with its f inverse, give us its square root of x, okay? And the graph, it's something like this, okay? And we know that. But now let's try to verify the derivative rule for f inverse. So first one, this equals 1 over f prime, right? Evaluated at its f inverse, okay? So first of all, guys, let's actually calculate what is derivative of its f inverse, right? So we can know this. Let me use a little bit of space here. So just want to verify this, okay? So f, the derivative of its f inverse, we just calculate which is the derivative of square root of x, right? As you learn from that, I'm going to give us 1 over 2 x to the power negative 1 over 2, which, if you simplify, this is the derivative of its f inverse, okay? But now let's try to see if the derivative rule for inverse works or not. And you see that to verify this, left hand side is equal to 1 over 2 square root of x. Right hand side is 1 over the derivative of the original function, okay guys? So f prime of x, do you see that it actually equals 2x, right? Super easy. What is f prime evaluated at its f inverse? F inverse is equal to 2 the square root of x. So do you agree this part is 2 square root of x, right? And then the reciprocal of that, do you see it's 1 over, 2 square root of x? Do you see those two parts match? That means okay. So far so good, okay? The derivative rule for inverse function actually works, okay? Now, let's actually do a little bit more, okay? Let's work on a problem like this, okay? I want to figure out what is the derivative of the f inverse evaluated for, okay? And based on the inverse derivative rule, or the derivative rule for inverse function, it equals the reciprocal of the derivative of the function evaluated at f inverse of 4. Agree? Right? So, okay. So let's take a look at it here, guys. First of all, let's again try to verify the left-hand side, okay? Which give us is what? We already know f inverse. Right? F inverse, and the derivative of f inverse, which is 1 over 2 square root of x. So f inverse, the derivative evaluated 4, which equals 1 over 2 times square root of 4, which give us is 1 over 4, because square root of 4 equals 2, okay? So we already know the answer for the left-hand side. Let's again, just to verify if it's valid for our inverse derivative rule. And f prime of x, I already know that, which is 2x. All I need to know is to figure out what is f inverse of 4, right? Because I know this, I can just substitute it to this part and I'm done, okay? F inverse of 4, guys, how do we do that? Well, f inverse of 4, which is here, So which give us is square root of 4 equals 2, right? And f inverse of 4 equals 2, and f prime of 2. F prime of 2, do you agree is 2 times 2 equals 4? The reciprocal, do you see that? It also equals 1 over 4. So the theorem works, okay? However, guys, before we stop here, I would also like to make one note here, okay? So in this problem, you see, I'm trying to figure out f inverse of 4 equals 2, right? Through this. But sometimes I really do not want to figure out what is f inverse, because a lot of time to figure out the inverse function, it might be very complex. Then how do I figure out f inverse of 4? Well, the idea is, you see guys, you are looking for f inverse of 4 equals, I don't know, suppose it equals, let's see, n, okay? This n or n. But you see, guys, because of the function and its inverse, do you realize that if I apply a f of x on both sides, there's a left side f and f inverse, so it becomes 4, right? So that means we are looking for a number such that that number m, such that f of m equals 4. And you look at our function f of x equals x squared. In other words, which number, when you square it, gives you the 4. And that number is a positive number. Apparently, you can figure out that m gonna be 2. So f inverse of 4 equals 2 based on the property about the inverse function, okay? So meaning you do not have to solve this. We solve this f inverse is trying to show you that the derivative rule for the inverse function, it actually works, okay? But in real problem solving, using the properties of the inverse function actually, and also associated with this, can help you save tons of time. Why? Because first of all, the derivative of fx, we know that because the function fx is always given, okay? And then you know, especially you are evaluating a specific value, the little bit tricky part is to figure out how to figure out f inverse of 4, okay? And how do we do that? Again, based on the property about the inverse function, okay? So this is the second part. Well, I would say third part because the video disconnected in a minute. And then we're going to talk about a little bit more about the logarithm derivative, okay? So I'll see you soon.